So whether you're new to 3D printing or you're a seasoned professional, one of the things you have to know how to do is to correctly tune your 3D printer to print with any given parts or filament. So whether I've changed out my hot end, my nozzle, or my extruder, or I have a brand new roll of filament I've never printed with before, I need to go through a certain set of steps in order to get that new part or filament printing at its peak efficiency. So that's what I'm going to be going over today in this video. I'm going to show you how I do it in this Kersey Fabrications 3D printing tutorial. Let's get to it. This video is sponsored by PCBWay. Have you ever considered taking your making to the next level by designing your own custom PCB for a project? Well, if you have, check out YouTube. There are a lot of excellent getting started tutorials on how to get started with the design process. But when it comes time to order your board, check out PCBWay. They have excellent prices and excellent turnarounds on your first PCBs. $5, 10 pieces, build time 24 hours, and you're done. It shows up right to your door, ready for assembly. Now, if you've got a great idea for a PCB, whether it's your first board or your 20th board, check out PCBWay's 4th PCB design contest. You can compete in one of 3 categories, either the IoT, the robotics, or the free theme category, depending on what you're designing. Excellent prizes all around. First prize is $1,500 cash, plus a $200 coupon, plus a Raspberry Pi 4G. So what are you waiting on? Get started with your PCB design, and thank you to PCBWay for sponsoring this video. So to recap real quick, when do I recommend using the steps in this video to tune your 3D printer? So if you change out any components in the filament delivery system, you should run these steps because that means that something has changed, whether it's the extruder, the hot end, the nozzle. Any of those components can make major changes in the way that your 3D printer prints. So you should definitely go through these steps anytime you make any of those changes. But as I mentioned, say I have a new roll of 3D printing filament that I've never used before. So in this video, I'm going to be using this BIQ PLA Premium, and this is the BIQ Blue filament. It's important that I go through these steps so I know exactly how this filament prints. Now, of course, if you're used to printing PLA, almost all of your PLA seems to print the same, and when you test this on a small model, you don't have any problems. Obviously, you're good to go. But I still recommend it if you're seeing stringing, if you're not quite sure why you're getting some blobbing. That probably means you should do a little bit of tweaking. So, what are the steps I'm going to be going over in this video? First of all, we're going to do a temperature tower to see the best temperature to print this filament at. Second off, we're going to tune our retraction distance to see what retraction distance best for this filament in conjunction with your hot end so that we don't get any extra stringing or blobbing or anything like that. And then lastly, we're going to tune the retraction speed, which will hopefully get that dialed in just right for the best results. Now, one thing I recommend, if you haven't done it already, make sure you've already tuned your extruder before you go through the steps in this video. Make sure you have the correct steps per millimeter for your extruder, and if possible, make sure you've already figured out the flow rate for your nozzle and extruder combination, because that will make the things that I show you here in this video work even better. And if you haven't done that before, please follow this video link up here where I go over the steps to do that, which will make your process even easier. So without further ado, let's head over to the PC. I will show you how to generate a temperature tower using Cura. So the first thing we need to do is to go online and find a temperature tower that's going to do what we need it to do and have the temperature range that's going to be needed for our filament. Now, my favorite set of filament towers is this one right here. It's available on Thingiverse. It is the Smart Compact Temperature Calibration Tower by Gazuli. And the reason I like this one for 2 reasons. Number one, it comes in 4 different temperature ranges, which are terrific, and you can see those temperature ranges down here. He has them labeled PLA, PLA+, ABS, and PETG. And the second reason is, as you flip through these different images here, you'll see he has different images explaining why he designed the test this way. You can see that there's an overhang here, there's a bridge here, you've got this to test some stringing, and this is another overhang here. As you go further, you'll see the angles, and so there's a lot of detail here. Again, this is the favorite one. So you'll go to the thing files. I just recommend downloading the entire package, therefore you'll have the pieces you need when it is time to use them. So bring up your Cura here, and as you can see, I've already loaded up the one I'm going to need for my filament. Now, how did I decide that? Well, I look at the side of the box or go to the manufacturer's website and find out the range that the manufacturer has suggested for their filament. Again, I'm using this by QPLA Premium for this testing, and the filament temperature range is 195 to 235. There just happens to be this perfect one here that goes from 195 to 235. Now, if your temperature range is slightly different, just find the tower that closely matches the filament that you're printing, and hopefully that'll do the job. It doesn't have to be the perfect tower. Then what we want to do is go in and set up our basic settings. It's best to use a known good profile, one that you've printed with in the past for your printer that has particularly worked well, and then you'll make adjustments accordingly. Now, if you look at his settings on that page, he recommends a 15% infill. That's not particularly important, but I'll go with his recommendation. Next thing we want to do here is on the printing temperature. You'll want to set it to whatever this bottom temperature is here at the bottom of the tower. So on this one in particular, it is 235. You can see it right there. So I'm going to go 235 as the printing temperature. And, you know, set your bed temperature to whatever the recommended bed temperature is for that particular filament. And at this point, you should have your flow figured out for your nozzle and have that set right here. So in my case, it may be 94%. I'm going to set that right there, and then set your print speed to whatever your normal print speed is. Of course, you may go faster, you may go slower, just find a good average there. And then for your retraction settings, since we actually haven't tuned in retraction, since we're doing temperature first, pick a retraction distance that has either worked well for this printer or for these components, or if you're not 100% sure, you're going to pick something that is average for the type of extruder you have. So I recommend something in the 1 to 3 millimeter range. If you're working with a direct drive, you may want something in the 5 to 7 millimeter range if you're working with a Bowden. This is a brand new direct drive for me, so I'm going to just set it to 2 for now, because that's probably an average retraction that may work well on here. And now it's time to get to the fun part, which is where we're actually going to have to go in here and set these change distances to make sure that as it goes up, it changes temperature. So at this point, we need to figure out what the distance at each layer height is so that we can change the temperature at specific height. So we're going to go back over to our page, which will explain the geometry of this build. So you can see right here that he explains that one floor is exactly 10 millimeters high, and the stand is 1.4 millimeters high. So with that information, we can see that our first change is going to be at 11.4 millimeters, because that's 10 plus 1.4, and then we're going to just add 10 each time, so 11.4 millimeters, 21.4 millimeters, and so on until we get to the very top. Now, how do we do that? We need to go into the extensions, we're going to go to post-processing, and we're going to go to modify G-code. And then once this post-processing plugin pops up, we say add script, and we're going to say change at Z521 experimental. Don't worry about the experimental part. I've obviously tested this and it works just fine. So that brings up one of these. Now we first need to make sure, number one, it's enabled. Number two, we're going to trigger at a specific height. Which height? As I said, the first one is going to be 11.4. We're going to apply this to target layer plus the subsequent layers. And then what are we going to change? We are going to change the extruder 1 temp, and we're going to set it to whatever our next one is. Again, we started at 235, so the next one is at 230. Now we've covered this one, and we can just keep adding scripts and make our way up. Again, this one's going to be 21.4, target layer, and then we're again going to set our extruder temperature. The next one's going to be 225, and so on and so forth. So let me go ahead right now. I'm going to add one for every layer all the way up to 195 degrees. All right, so then once we're done adding all of these, let's go back through. We're going to make sure our change heights are sequential, and we're going to make sure that our extruder temps are decrementing. Once we have all that set, we are ready to slice this model. This particular print is going to take almost 3 hours because we're only printing at 50 millimeters per second. I can go ahead, let's go ahead and set this to whatever we want so that it's a little bit more readable. And we are ready to save to removable. And we are ready to eject and go. So let's head back to the printer and actually get this printed. Alright, all done. Now let's take a look at the results and see how to evaluate this test. First of all, I think the most obvious thing you can see on this print is the stringing at higher temperatures. And very apparent here and here because it's almost covering the back area. But we'll notice that we actually get a little bit of stringing all the way up to this 215 mark, where we still have a little bit here. Now, there's a little wispiness on 210, but since we haven't dialed in the retraction settings, we won't rule that one out yet. Now from there we can start looking at things like overhangs. So if we look at the side here and take a look at the overhang, I don't really notice a huge difference in the overhang. I think it's possibly a little bit worse all the way up until maybe this area. It's just mildly better. And we're getting some better cooling at the lower temperatures. But overall, the overhangs look pretty good. And on this side as well, no significant difference in overhangs no matter what temperature we're at. So next up, let's go and look inside these little dots here. Again, we're going to start looking about the 215, 210 range. And we're going to look in here. We want to see how sharp our points are, as well as whether there's any stringing inside of these areas. And you'll notice here, I think my favorite one is in the 205, 200 range would be my pick. So somewhere in this range is going to be our ideal temperature. I would say anywhere 200 to 210 looks really good. Maybe we're just going to go ahead in the 205 range, and that's going to be our target temperature for now. I hope that helped you understand exactly what we're looking for. So now that we have a temperature for this filament, let's head back to the computer and let's see how we're going to dial in retraction. Okay, so the next thing we're going to need is a basic stringing test, something that we can rapidly print, change a setting, print another one, and just go through the motions. My favorite test is available on Thingiverse. It is the smaller base stringing test. This one uses the minimum amount of filament. It doesn't take long to print at all, and it is a good test for just basic retraction settings. So go ahead and pull this one down. Again, this one is by Bar Toaster, and it's been around for quite some time. Then if we pull that into Cura, you'll see it orients this way. This is our front left corner. I like to then turn this around 90 degrees so that it is facing forward. It doesn't really matter for the stringing test which way you go, but I like this orientation, just makes it easier to see. So the next thing we want to do, we don't really need to change a whole lot of settings from what we were running on the last test. Obviously we need to set our printing temperature. It's going to be 205 here, and make sure you don't forget to go into your post-processing plugins. Either delete them or disable them, whichever one you want to do. I'm going to go in and just disable them, which will allow me to easily go back and test this again later. Now we won't have to worry about this getting in our way or making changes to our print as we're going. So next up, again, set the new temperature, which we decided was 205, and we have a flow that we have set from previous testing as well. So the next thing we want to do is set our lowest retraction distance and then work our way up until we find the lowest retraction setting that seems to work well. We're going to come back in a minute and do the speed because we need to do these independently, otherwise we don't know what's actually making the change. So if you're working with a direct drive, you can actually do your first one at 0 just to see what it looks like, and then go up half millimeter increments from there. Tune even finer if you want to later on. If you're working with a Bowden extruder, you may want to start with 3 millimeters or 4 millimeters, whatever you have seen that has worked for you in the past, or potentially what you have found online that other people recommend you can try with that retraction distance. I'm actually going to start with 0 on mine because that gives me a baseline. That shows me what it prints like if I don't set any retraction at all, and then I can come up here. Make sure you also set this wipe distance if you're using Cura, because this actually makes a big difference on a lot of prints. It should make a big difference here. My rule of thumb, and this is one I came up with myself, is to set that wipe distance to whatever your nozzle diameter is, in this case 0.4 millimeters. Then I'm going to do a slice. You'll see here in the preview everything looks proper. Now if this isn't sticking well to your bed, be sure to print it with a brim. It'll stick a lot better, but I think this will print just fine on my bed. Notice this is just a 15-minute print. It's going to print quickly, and then I can come in here and make adjustments accordingly. So I'm going to run this test as well as a few more tests now, and then I will come back to you, show you the results of each of those tests as I change my retraction settings. Using those, I'm going to show you what I was looking for and show you the results. Then we'll come in here if we need to and do a little tuning of that retraction speed. Oh, and one more thing. When I go to save these to my SD card, I usually like to change the name down here in the lower left to reflect the settings of this particular retraction setting. Then if I want to go back, recheck something because I wasn't sure about the results, it's easy to just go run another print rather than having to go and reslice it. So right here, I've just gone in, I've done an underscore, I've set 0 for my retraction distance, I've set 25, which is my retraction speed. Again, really easy to look at the file and then reprint this later if I want to. So as you can see, that didn't take long at all. In fact, we have only 2 prints here. The one on the left is the 0 millimeter retraction, and honestly looks really good for 0 millimeters, but obviously not what we're looking for. The one on the right here though, this is the 1/2 millimeter retraction, and it is about ready to go. As you can see, the only thing that was here was a couple wisps, one on the right hand top and then one between them. So I'm hoping I can just keep it at a 1/2 millimeter here, then play with retraction speed to get it just perfect. So that's where we'll go now. We'll play with retraction speed. If that still doesn't work, maybe we'll just go like 1/4 of a millimeter longer and see if that takes care of it. But let's go take a look at how we change the retraction speed. All right, back in Cura, we're going to set that retraction to the distance that we noted for that print, which was 0.5. Now, whether to go faster or slower, it's very difficult to tell which one is going to be the answer here. I think I'm going to go faster because I started low at 25. So I'm going to go for a 35 and see how it reacts. If it gets worse, obviously, maybe we went the wrong way. If it gets better, then we're on the right track. So I'm going to do a 0.5 at 35, and we will see how this one looks. So after all of that, these represent all the different tests I ran to try to get the absolutely perfect tower with no stringing whatsoever. In the end, I found out I couldn't really get one that had 0 stringing, so I end up with ones that just have the tiniest of wisps. And so I'm going to end up with a 1/2 millimeter retraction at 45 millimeters per second, and that's what I'm going to do my final test with. So one more time, back to the computer to just show you the final test that I run before I call it done. And here's the last test that I'm going to run. This is the stringing retraction test, and notice it is uploaded under my account, but as I say down here, I'm not the original author. I found this one years ago and then could never find the original author, so I re-uploaded it for use. But this is my favorite one to run as a final test, just to make sure everything's tuned in well enough. I like this because you get a lot of movement, you get movement in different directions, and so it's just a great test. And as you go up towards the top of these spikes, I do think you normally see a little bit of stringing, but you want to make sure at least on, you know, the bottom 80% of these spikes that you are getting good retraction results. So I've imported that into my Cura, and as I mentioned, I have set my retraction settings accordingly. We have the 0.5 distance and the 45 millimeter per second retraction. I'm going to slice that. We're then going to save that to our drive as usual. Of course, you can come down here and like I've done in the past, I can go ahead and say which one this is. I can go put 0.5 and 45, and I can say save to removable drive. This will be my final test. Let's see how this one goes, and then I'll sum it all up. Oh, and one more thing I forgot to mention on this one is most likely you're going to need brim set for the plate adhesion. Otherwise, these are going to most likely break off while you're printing. So go ahead and set brim on here, reslice, you'll be ready to go. So here are the final results of my stringing test. This has my final retraction settings of 1/2 millimeter at 45 millimeters per second. And almost all of the stringing that I'm seeing in this print is limited to the very tops of these towers, which is where it has no wiping and very little time to even lay down any filament. So that's acceptable. The rest of the base is pretty clear, and even some of that you're seeing is just strings that have fallen from the top of the model. So overall, I'm really happy with this. So let's sum up what we've done here. All right, so here we are. We have all of our calibration models, we've got our temperature tower, and we still have the print I just finished on the bed. Everything is tuned. While it may not always be perfect, it's definitely tuned enough to produce some really good prints. So while I go over what we did one more time, I want to go ahead and put up here all of my Patreon supporters who have made this video possible. So thank you to them. If you'd like to support this channel like they have, please check out the link in the description. So what have we done in this video? Well, first of all, I ran a temperature tower with my new filament at a reasonable retraction setting, and we found out what the best temperature for this particular filament was. Now, special thanks to BIQ for providing this filament today. This is their BIQ PLA Premium, and it printed really well in this video. I will be taking a look at it more in another video in the future. Second thing we did, once we had our temperature set up correctly, we ran a whole lot of stringing tests to get that retraction dialed in just right. So first we dialed in the retraction distance, then we played a little bit with the speed to just tweak it that much more. Once we thought we had all of that set up correctly, we ran one final test that's a bit more extreme just to see how we did, to see if there was any more tweaking that we wanted to do. And that about does it. That's my process for tweaking just about any filament that I'm going to run that I haven't run before, or with any changes mechanically that I've done to the printer. These are the steps that I follow. Now keep in mind, if you're printing other types of filament, such as flexible filaments or certain types of filaments that don't require hot end cooling, there are other settings you're going to have to tweak, and I hope that I can cover those in a future video specifically about those materials. But that's it for this video. If you've enjoyed this content, please leave a like behind when you leave, and if you want to see more of this content, go ahead and click that subscribe button and click that little bell, and you'll be notified when I release future content. Thank you so much for watching. I am Chris, and this has been Kersey Fabrications, and I will see you guys next time. Thanks for watching.